Hey everyone, welcome back. I guess we're going to keep diving into this. Next up is autopilots. See what you need to know about these. Automatic flight is important not only because it frees the human pilot from continuously flying the aircraft, but it flies the aircraft with a greater degree of precision and can navigate by coupling onto the various electronic navigation aids. And it is, as you can see, there's no road here. So basically, the the trip is not as eventful for for a pilot as it is a regular motorist. Motorists, you have to basically keep driving. But with an aircraft, as long as you got it pointed in the right direction, and with all these complicated instruments, you should get it so it should be able to mimic the little bit of movement that you have to do for the flight surfaces, particularly when you're in at your cruising speed, and you're in what they would say level flight. AFCS, that's the whole basket of flight controls, including the autopilot primarily. We'll also talk a little bit about these other ones. The aircraft axes, if you haven't already saw them, I know it's more for aerodynamics and maybe more for pilots, but there are three axes. The pitch, which is in effect the long axis, the longitudinal axis, which basically the aircraft will either be nose up, as in this illustration, or nose down on that imaginary line, which is in effect an axis. And then when the plane moves from right to left, it's in effect revolving like like something balanced on a stick along its yaw axis, or it's more for the length of the wings, which would be lateral. There, what controls that is the rudder, and then the last one is the roll. And am I saying these correctly? I might be. All right, so not a very good illustration here. I'm sorry. This probably isn't the best way to explain the three axes. Just be aware that there are three. If the pilot moves the elevator by, in effect, moving the yoke forward or back, the pilot changes the pitch of the aircraft. And if the pilot moves the foot pedals, which controls the rudders, one side or the other, you can actually move the rudder and cause the plane to point a different direction. And the ailerons on the tips of the wings, that basically allows the pilot to bank the aircraft or to resume it back into a level flight. The primary purpose of an autopilot is to relieve the pilot of the control of the aircraft during long periods of flight. Oops, I guess I read that last part a little premature, because that is the question. What is the primary purpose of an autopilot? And as we just said, C, to relieve the pilot of control of the aircraft during long periods of flight. Some people may believe that it's a more precise course. It may be slight movements of the aircraft may be more precise, but the course wouldn't be any more precise with an autopilot. to obtain the navigational aid necessary for extended overwater flights. Again, it's not really a navigation item. I mean, we are covering it here. As a matter of fact, some courses actually will put Autopilot in the instrument section. For some reason, we are covering it here in communications and navigation. So it makes it seem like there's actually navigation. It's in effect a cruise control for an airplane, only a little more involved than that. All right, this is an older presentation. I'll just have to bear with it. Okay, this is a little better. I like this vertical axis. That's what was throwing me 2 slides ago. The yaw, that doesn't really look vertical, does it? Looks like it's diagonal to the aircraft. It doesn't look like a pole that goes from top to bottom. That's what threw me off. This one here, much better. The vertical axis, and that's what causes the plane. You can imagine if it was a toy with a stick going through where the vertical axis is, you could basically make it turn from side to side, which is what the rudder does. The longitudinal, I think of it as from the nose to the tail, the longest. It may not, sometimes the wingspan is actually greater than the length of the aircraft itself, but in most cases the length of the aircraft is longer than the wingtip to wingtip. Wingtip to wingtip is the lateral, and nose to tail is the long. And again, if you held an imaginary stick through the wings, you can imagine you can make it roll up and down. Or I guess the term would not actually be roll, but it's pitch or I think it is just pitch. And that's what the elevator. And then the final one is shown by this dotted line, the longitudinal. If you had the imaginary stick, you could make there's the roll. You can actually roll the aircraft. And you do that with the ailerons. The autopilot usually operates off all 3 of those axes. So it can basically make a little adjustment on the rudder or the ailerons or the elevator, depending on the instruments being interpreted by, well, here's the instruments. Consists of a directional gyro. These are the sensing elements. A turn and slip rate gyro, attitude gyro, and an altitude sensor. So it's mostly gyroscopes that are basically measuring the orientation of the plane in space, and the altitude sensor, which could be just a regular altimeter. Those go into a computer. There's controls that the pilot would have, turning it on and off and making some slight adjustments. And those are the command elements. And then the output elements, basically signals are sent to little motors, which are called servos, which are attached to the various flight controls that we just talked about, the aileron, rudder, and elevator. And a trim servo, because that's the more comfortable one. Rather than holding the yoke in one space, in one spot, which would get to be tiring not only on the pilot, but even I would imagine on the autopilot controls. If you can adjust the trim a little bit, you're actually taking pressure off you holding it into one space, one spot. You can relax in after that. And the autopilot will do that for you also. Output elements. Here's a block diagram, basically the same thing. Sensors, computer to servos. What are the PCAs? Primary flight control? No, I guess they're over here. All right, I don't recall PCAs in this connection, but question. A fully integrated autopilot controls the aircraft around how many axes? Is that 4, 2, 3, and your instructor may add a fourth option like 8. All right, so the correct answer is all 3, the primary 3 axes. The elevator channel of an autopilot controls the aircraft about which axis of rotation? So the elevator, that's the little flaps attached to the horizontal stabilizer in the back, which basically makes the nose of the plane pitch up or down. Think about where it would be pitched, and then think about where you would put the stick through the little airplane model, and you would go wingtip to wingtip, which that one was the lateral axis. Wingtip to wingtip. Roll and longitudinal are actually the same thing, so. Which channel of an autopilot detects changes in pitch attitude of an aircraft? In effect, they're asking the same question. This time, they're not telling you what axis it is. They're just telling you what the pitch, roll, or yaw, which one of the 3, and then you have to match it up with what flight control can you adjust the pitch? How do you pitch the nose up and down? You do that with the elevator. So it must be the elevator channel of the autopilot, B. This illustrates the basic operation of an autopilot. I think it's just more of the same of what we've already looked at. The controller, in effect, on and off. A little bit of fine tuning here. Ring laser gyros are the most common use of sensors for an autopilot. It's not really a conventional gyroscope, but it uses, in effect, corner prisms to bounce a laser light, and it detects changes in the aircraft's orientation with space. And apparently you would have one of these for each of the axes. So this would, depending on how it's attached, could detect one of the 3. Ring laser gyros. In which control element of an autopilot system is an attitude indicator? Attitude, that's not the altitude, that's the other similar word. That's the attitude or the orientation of the aircraft in space. And in an autopilot system, that is in effect the instrument telling the computer what to do, or to tell the computer that it needs to tell the servo what to do. So of the 3, Well, it's not the command because that's computer. It is actually either A or C. I guess the correct word is going to be sensing, but not a kind of a poorly written question. And as you can see, I got this from an old textbook source. So I can't swear that this is the latest and greatest version. I certainly will make sure that any new questions are covered, though. Sensing? Yes. What component is the sensing device in an electromechanical autopilot system? Is that the gyro, the servo, or the controller? Well, it's those ring gyros, or in the older days, it's just a regular gyro. An attitude indicator is actually is a gyro inside of it. So that's the sensing portion. Gyro. Directional gyro, turn and bank gyro, attitude gyro, and of course that altimeter. What is the operating principle of the sensing device used on an autopilot system? Again, are they looking for the word gyro? Oh, they must be because it's in all three of the options. All right, so what's the operating principle? A, the rate of change of motion between the gyro, gimbal rings, and the aircraft. Not a bad answer. B, the reaction of the force 90 degrees away from the applied force to the direction of the gyro rotation. They're describing precession there, but that is something you should know about with gyros, but it's not something that is incorporated into the sensing device. Or C, the relative motion between a gyro and its supporting system. Much better, broader answer than A. Actually, after rereading A, C does sound even better yet. The relative motion between a gyro and its supporting system. So the gyro is, in effect, set in space, and the aircraft around it might be moving, so it's the relative motion between the aircraft in effect moving and the gyroscope being fixed in space. What are the sensing elements of an autopilot system? All right, we've read them off like 3 times now. Attitude indicator, turn and slip, gyro. The last one was the altitude sensor, or altimeter, I've been calling it. And what do we got? We got the, did we already say attitude? What was the third one? The directional gyro? No, I'll tell you, 3 out of 4 isn't bad. Oh, it is the directional gyro. Okay, attitude, directional and turning gyros. That's a turn and slip, and an altitude sensor. When operationally checking an autopilot system on the ground, after the aircraft's main power has been switched on, the autopilot should be engaged. Well, they're telling you right there that you can check it on the ground. So, A, only after the gyros come up to speed and the amplifier warms up. This should be a give me if you get this one. That is the correct answer. It takes the gyro a little bit to come up to speed. You can test it only for a few minutes at a time. Well, it can be operated continuously, so there's no restriction on actually testing it. C, whenever the operator desires. So as soon as you turn on the main power, No, you do have to wait the minute or so. A. They do struggle to come up with some maintenance questions around an autopilot, as you can tell. It's they're certainly easy to ask. You know, uh, pilot type questions, or maybe even engineer type questions about the inside. But a regular maintenance person, if you are going to test it, you should at least let the gyros come up to speed and the amplifiers warm up before you engage it. All right. All right. Thank you for joining me again, and I'll see you on part 2 of Autopilot.